Yeah.
Well, that's not easy.
Yeah, even Jay's on my 2020.
I literally made a whole presentation. Like that was my last presentation.
It's just for the stats,
Of
just for
why
the
you
stats.
should not. I well, I don't know. Essentially, just like why you should not look at college grades, which are all wrong. All of the statistics in the training are wrong.
See the exam though?
Okay, well,
Yeah,
it's
yeah.
just the stats. The stats are wrong.
Well, if you take away the middle line.
It's like, look at freaking difficult. No, that's what you can't teach.
This, so,
Did I heard it's the birthday?
All right.
admission.
You remember multiplication table, right? Okay, so multiplication table is one of the things that you constantly using throughout your life. So this table here is called unit circle. You're gonna continuous use throughout this half year. And so some of your students will go into calculus next year. You'll continuous use this next year. So it's one of the things that you'll be continuous using. So if I were you, I will try to understand the first time correctly and try to really focus on lock in to understand things, because this is gonna be the second half. Depends on how, like, the success that the success of the course really depends on if you know this inside out. So I'm gonna start by going through all the stuff. If you don't understand it, it's okay. Ask questions. Please don't zone out, Arthur. Please don't fall asleep, Isla and Devin. And then really try to understand this completely. If you have any question, ask questions. The best thing to understand it is the first time. Always the best way to learn something is the first time you're learning it. Because second time you become complacent. You're like, oh, okay, I don't need to know this. I don't need to know this. So even you already know, for example, Alexis, Anthony, or Devin, you guys already learned a little bit. You still have to pay attention because every time there's something to be learned. I will tell you for experience. Every time I teach this, I learn new things. And that's just me been teaching for the last 10 years. So it doesn't mean that you already know it, you don't need to listen. No, you know it, you still have to understand. There's always things to be learned, and then there's always things that you can get better. You know, if you want to be perfect at something, usually you try to understand the first time really well, and then still keep on building on top of it. You cannot just say, oh, okay, I'm just let it go, because I already learned it. I cannot let you do that. Okay, so what we're gonna do is we're gonna go through this unit circle together and going through all the degrees and angles. So we're gonna break up to like maybe 2 parts. Now, a lot of you guys, another thing is a lot of you guys will go into TikTok or go into Instant Reel to learn about this unit circle. I will prefer you don't, because in that particular way, they have some finger way to teach you to memorize the units. I will say it's not productive and it's not truly understand. And if not truly understand, you cannot apply as well. if you do it right the first time, for me as a student, I learned this unit circle in like in one period of time, and I understand everything. I can recite it, everything. I can fill in all the blank without problem. You are gonna have exact same quiz of this front and back. Okay, first time it's gonna be the front. So you will have 7 minutes to finish. If you got one mistake, that's gonna be automatically 0. Okay? But so for the smart people will actually understand the first time. Can you get to retake? Yes. But the second time you retake is 6 minutes. You had to get it right. And then 5, and then 4, and then 3. So the smarter way is learn it the first time, so you have 7 minutes. Because when you get down to 3 minutes, it's kind of crunch. And that's what dumb people do. Take forever to learn something. And I mean, I'm sorry, but just if I were you, I would try to perfect it the first time. So I don't have to fall into the trap says time is gonna be a problem. 60% of student does fill up the first time in 7 minutes usually. And the other 40%, sometimes some students take longer. Some people get down to 3 minutes. Some people get down to 2 minutes. You can't really finish in 2 minutes. You have to be really, really, really fast. But then you have to understand them, not just only memorize where the location is. You have to memorize where they are. And I'll print out more copy. I don't have enough printout today. So we're gonna go do that. Now, like I said, you're gonna consistently using throughout the whole second semester. And your AP exam score really depend on how much you understand this, even though it's one page front and back. Now, there's second page here in the back. It's all the formula sheets. There's the formulas of what you're gonna use throughout this year and next year. So you're gonna have a lot of time BC students still using some of the formula on the bottom. They still using it. So like I say, learn it the first time. You don't want to learn the second time. Okay, so what we're gonna do is, if you got color coded, it's good if you can color code them. If you cannot, that's okay either. You can just write down one thing. It's not a big deal.
It's not like climbing it, like you can, you know, like don't worry. That's just me, I guess. I was gonna take it.
Oh my gosh. I have 12.
I have no way already. Ew, don't do this. Dude, you see the both of them?
Oh.
All right, so this unit circle looks really big, but according to Cartesian coordinate, like Cartesian coordinate is like this. So first of all, this is a very, very microscopic of something. This is a Cartesian coordinate, and that just show you the scale wise. This point is 2, 3. This circle is actually just as big as this. It's just big as that. That's it. In this circle, it has 90 degree, 180 degree, 360 degree, 45 degrees. It has all those things. But this is 2, 3. So everything is within 1, 0, 0, 1, -1, 0, and 0, -1. Everything's within here. So this is a Cartesian coordinate. Cartesian coordinate is what you use for graphing and everything. So it's just this small, tiny circle. We blow it up a little bit to make it look like this. Okay, so we make it bigger to show you what happened. Now we're gonna start with the degrees, and I'm gonna show you how to convert degree to angle, radian to degree to radian. Last time we will kind of review because we talked about what is radian last year. I don't know if you remember what is radian. Did anybody remember what's radian? 1 radian is represented in terms of degrees. No. Yes, Roger.
Pi over 180.
I'm on the right track, but no. Yes. 180 over pi, yes. Okay. So let's start with a circle. A circle has, if you know, a circle has 360 degrees. So this is a circle. So 180 degree is also known as a pi. So therefore, 360 is 2 pi. So 180 degree is 1 pi radian. And most of you guys don't know what pi radian means. Remember, I'm gonna refresh your memory. There's 2 types of measurement of angle. One is the one you know, degrees, right? 180 degree, 90 degree, 30 degree, 60 degree. We know that. But who says why is a circle 360 degree? It's so hard to think of 360 and memorize that number. Why can't I just make it 400 degrees or even 1,000 degree, right? This makes it easier why it's 360 degrees. And that 360 is a number can divide it by a lot of numbers. So 360 can divide it by 1, 2, 3, 4, 5, 6. Can it be 8? 8, yeah. 10, 12, 15, 20, 30, 45, 60, 90, 180, 100, and 360. It can be divided by both number. Okay. So it can divide it by all those number. So 180 equal to pi radian. So that's going to give you 2 conversion ratio. Remember last year we talked about this? 180 degree over pi radian. Or, and this is going to be on SAT, pi radian over 180 degrees. So either or is a conversion ratio. If you guys take Mr. Waddell's class, you guys should learn how to do dimension analysis. How do you change one dimension to another dimension? Or changing from moles to how many moles to the gas, right? Do you guys remember 1 mole of gas is how many liters? Mm-mm. 1 mole of a gas in the standard in the STP is 21.4 liter.
Yes. Yeah, it's 22.
Oh no, you haven't learned that yet.
They haven't learned mold. It's like
We just started today.
oh.
Oh, it just started today. Good. So I'm gonna teach you how to convert. So you're gonna have to know how to convert from one thing to the other thing. So that just says today. I'm just review. So let's say today I have a 50 degrees. I want to convert to radians. I can convert them. I want to make sure the degrees on the bottom, and then you can say 180 degrees over pi radian, and then that is going to be 5 over 18 pi radian. So if I change 50 degrees, this is 5 over 18 pi radian. Okay, Devin, you need to go wash your face and come back. Okay, so 50 degrees can change to 5 pi radian over 18. Why? Because 50 over 180 is 5 over 18. And so you can say that's also is 5 over 18 pi. You can convert back 5 over 18 pi. Now remember, we can either choose this one or this one, right? which one I should choose? Sorry, this one pi is on the top. Which one should I choose? First one or second one? What? First one, why? Because it cancel the pi radian, because it can simplify the pi radian, right? So pi radian, and this 180 degrees. So this pi and pi radian can cancel out. And this 18 and this cancel out is 10. And 10 times 50, so it's 50 degrees. So I can convert back to 50 degrees. And that's how you convert from degree to radian, radian to degrees. That's really fresh. What's radian mean? A radian for example, this circle has a center. And we're going to call it center C. And it has a radius. This is a radius. Arc length. This arc length, if this arc length is equal to R. So that just say if this arc length is equal to R. Then this angle is known as the 1 radian. It's known as 1 radian because that opening is going to be 1 radian. And 1 radian is roughly 57.3 degrees. Roughly equal to 57.3 degrees. Why is it 57.3 degrees? It's 180 over pi. So you take a calculator, you do 180 divided by 3.14. If you take 180 divided by 3.14, it's going to be 57.3 degrees. In that opening where this radius from here to here, this radius from here to here is the same length from here to here. Always universal. It doesn't matter how big the circle is. It doesn't matter how small the circle is. The circle could be big as the Earth or the Sun. They follow exact same way. 57.3 degrees. 1 radian. Okay, it's always 180 divided by pi. Now, rest of this just our multiplication and division, and you should understand this pretty easily. So I'm gonna go through it really quickly, but I'm gonna color code all this. If I color code, this one's gonna be 0 and this 360. I use black because these are all important values. Everybody should know this. I use blue, I'm sorry. I'm gonna use black right now. This one is gonna be, I use black. So it'll be 0, 90, 180, and 270 and 360. And everybody should know that. Now, if I break the 90 to half, right? So the half is right between here, right? What's a half of 90? So that should be 45. Now, I'm going to use a purple here, or it doesn't matter which color. You just have to pick any random color. That's going to be 45 degrees. And what's halfway between 90 to 180? No, 90 to 180. What's a half between 90 to 180? 135. Good. 135 is still in purple. Now your color could be different. So if you realize this opening from here to here is exactly 45 degrees. So you can subtract 45 degrees to get 135. Or you can add 45 degree, right? So what will this be? What will be this degree here be? 225.
Oh, it's just how much you bench.
Okay, this is how much Arthur can bench. I don't know.
Yeah.
Can you?
No.
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 That's weak.
How much do you bench?
What's your benefit?
20. I'm just kidding. I don't know.
Nick, how much do you bench?
That.
225? That makes sense. Nick's a strong man.
Okay, so 225. So the next one is gonna be here. So what is the angle here, Isla? 345 is not right.
Wait, I'm like.
Bro.
Oh wait, give me a second.
It's just 6 times 45. 15.
250.
315. You need Arthur to help you? That's
Guys, it's not my.
All right. So that's 45 degrees. Now I use purple for that 45 degree. It's called, by the way, they're all 45 degrees because they all have a purple color. It means they have the same reference angle. Now you're gonna be like, hey, Mr. Ye, what is reference angle? I'm gonna explain to you what's reference angle. So you might want to write it down. What is a reference angle?
Write down on paper.
You can write down a notebook. So what's a reference angle? Reference angle is angle from with the terminal side to the closest x-axis. So phone with the closest axis, closest x-axis. So what do you mean by terminal side?
Oh, we can't see.
Who is this person? With the closest. I'm gonna show you. Give me a second.
Lock in. Ellen, you have to remember.
You're right.
135.
130.
Okay?
130.
45 to mine stone, okay?
Good, yeah.
135.
235.
How does that?
225.
And then? Don't look
350.
down, bro.
350.
All you gotta know, 215, 225 is a man's goal. 315 is a man's dream. 335 is a boy's dream. And 45 is a girl.
That's a good way to look at it. I don't know why it's not connected.
45 is the bar, Ella. Come on.
Yeah.
45 degrees.
Mr. Ye, the bar weighs 45 pounds. One plate on it, it becomes 135. With two plates on, it's 225.
And then 3 plates.
315.
Yeah.
You know, 4 plates, 4 or 5. 5 plates, 495.
Why are you still going?
Yeah.
Oh, yeah. What's your squat?
Squat.
495?
225?
Yeah.
So many pictures.
I don't think I'm not strong enough.
I don't know why I cannot connect the office.
Holy mother. How are you?
Oh, yeah. How about that? I put that one down. What about that?
Yes.
Wait, what do you mean? Just know what I'm doing.
You know,
I'm not prepared.
oh, I was curious.
You're gonna stop.
Damn it, I want to solve your highway.
You're not shooting.
You won't be able to. Why are you going on?
All right, so I was not I don't know why it's what's wrong with the thing. So I will go through. I will go through. So start with this is 0, this is 90, this is a 180, this is a 270, this is a 360. And 45 is I will use purple color here. And here is 135. This is 225. This is 315. Okay, so now I will use different color. I'll probably use green or red. This green part right here, the first spoke here, this will be 30 degrees. Okay. The first line here, there's 3 lines, right? There's 3 lines here. But the first line is going to be 30 degrees. Is that okay? And so what will be this line here?
60
What?
or no, 150.
150, good. Why 150? Because this angle opening is 30 degrees. They have same reference angle. This is called reference angle, formed with the closest x-axis. Do you see from here to here is the closest x-axis? That's why it's called reference angle. This is reference angle, this is reference angle. Are we okay?
Yeah. Yes.
Reference angle. So that's why they are the same color. Because 150 has a reference angle of 30 degrees. Just like 30 degree has a reference angle of 30 degrees. Is that okay? So that's why they categorize them color. So go to here. Go to right here. This is what? 210. They also have a same reference angle as the other one. They have same reference angle here. So what is this one here? 330. Any questions so far? No problem? Everybody else, no problem? If you have a problem, ask. Okay? 30 a problem?
330.
Yeah, 330. Understand that subtraction, how subtraction works. This part, this line is closer to x-axis. So if you see that first line, that's the closer to x-axis, that's 30 degrees apart. So here's gonna be 30 degrees, here's gonna be 30 degrees. So use 180 and 360 as a reference, so it's easy to figure out what the reference angle is. Are you okay so far? Okay. Next one is gonna be the one that closest to y-axis. What will be this one here?
What color?
You can choose any color. You just have to choose 3 different colors here. And I will show you why, because those color reference the same reference angle. What will be? This is 60, right? And what will be this one? 120, right? What will be this one? 240, good. What will be this one? 300. Is that okay? Because 60 degrees from here, adding 60, so 240. Subtract 60, it's going to be 600 or 300. Add 60, so all the black one have the same reference angle. All the black one has same reference. All the purple one has same reference angle. All the green one has same reference angle. They all the same reference angle. Reference angle is very important because you can use that as a reference, and you can figure out a lot of information about that part. Am I going too fast? No. We did that, right? We did it before? No? Okay. So now let's go figure out the radians. The radian is, start with a radian here. This one is going to be 0. And this is a pi. Because we say 180 degrees pi. So they should be have this place, you can put a radian. So this is a line, there's a degree, and there's a radian, right? Do you see this? There's a line with a hole on that. That's a degree. The line next to it is for radian. So the radian you're gonna put here is 0, and here's pi, and here is a pi over 2. Is that okay?
Yes.
Because pi divided by 2, because halfway, right? And this is 3 pi over 2. Three pi over 2. So I'm gonna say that again. 0. Is that okay? Pi, because 180 degrees, right? And then 2 pi. Sorry, I'm going to write down another one. There's 2 pi here. So 0 and 2 pi. It can be 0 or 2 pi. Now, 0, pi. This is pi over 2 because divided by 2. And this is 3 pi over 2. Why 3 pi over 2? Is 1.5 pi, right?
Can be either from 0 or 2 pi.
Yeah, it can be 0 or 2 pi. Yeah, there's 2 lines there. 1, 0, and 2 pi. So far, any questions? No questions? You sure? Okay. So now let's figure out what would be 45 degree. Nicholas, can you think about what would be 45 degree in terms of radians? No. Good try. No.
Yeah, that's a good one.
Okay, let me call somebody. Let's call
No problem.
let's call David.
Pi over 4.
Pi over 4. Why do you think it's pi over 4?
Because it's halfway between 0 and pi over 2.
Because David's family owns pizza.
Oh my god.
Right? So think about it in terms of pizza. The pizza is 1 pi. So this is a pi over 2. It's cut over half, right? If a half of a half is what?
4.
Pi over 4. Right? So this is a pi over 4. Are we okay here?
Yeah.
Because this is pi over 2, half of a half is pi over 4. Is that okay? Now, you say, well, what is this one? What would be this one? Let me call somebody. Chase, what do you think? How about 135? What would it be 135?
3 pi over 4.
Why do you think it's 3 pi over 4?
Because it's like another pi over 4 factor.
So think about it. If you have a pi over 2 and a plus pi over 4, right? So it'd be 3 pi over 4. Do you understand why it's 3 pi over 4?
No.
Okay, I'm going to show you why it's 3 pi over 4. Do you know why it's 3 pi over 4? You don't understand, right? So remember, this is a pi, right?
This is pi.
This is a pi, right? So can I say pi is also 4 pi over 4?
Yeah.
And
Okay, that's 3.
this is a 45 degree, so this pi over 4. So it'd be 4 pi over 4 subtract pi over 4.
Yeah, okay.
So therefore 3 pi over 4. Did everybody understand that part?
This is basically 1. Why is it not 2 next to it? That's 2 pi.
Wait, so 45 is pi over 4?
Yeah, 45 is pi over 4 because of half. 90 degrees pi over 2. This is pi over 4.
Okay,
Yeah.
5.
Yeah.
2
What
over
would
4.
60 degrees be? 2 pi over 4? What's the next one?
Well, not yet. We never get there. We only finish on pi over 4. So, everybody understand? This is pi over 4. This is 3 pi over 4. Now use the same color, right? Use the same color. Use the purple. For me, I use purple on this one. I will use purple on this one. Why? Because they all have the same reference angle. Can I say what's reference angle 3 pi over 4? It's what? What's reference angle 3 pi over 4? No, pi over 4. The reference angle is always the first quadrant. It's the distance from here to here. So the reference of 3 pi over 4 is what? Pi over 4. Now a third. I don't know where you get a third from. The same opening from here to here is pi over 4. The same opening from here to here is pi over 4. So that's why it was the closest x-axis.
Oh well.
And that's going to be pi over 4. So reference angle has to be between 0 to pi over 2. So right here it's going to be reference angle, it's going to be pi over 4. Is that okay? Okay. What would it be this one, Devin?
I think that will be 5 pi over 4.
Why do you think it's pi over 4?
Because if you add like what pi over 4, because there's already like
You have 4 pi over 4, you're adding,
what 1 pi over.
so it'll be 5 pi over 4. Does that make sense for everybody? Does that make sense? Same color, all the 45 degree, all the same color information. If you want to send coding, the same color information. I don't know which color you use. Unfortunately, my iPad's not working today. So the 5 pi over 4. What do you think this one is? Let's ask Darshini. What do you think? Darshini, what will be this one here?
3 pi.
Huh?
3 pi.
No. Sonali, what do you think?
7 pi.
Why do you think it's 7 pi over 4?
Because you said that 270 degrees is 3 pi over 2. Which is the equivalent to 6 pi over 4.
Right. 2 pi is equal to 8 pi over 4, right? So it's 1 less. So if you use this as a reference, use this x-axis as a reference. That's why the reference angle. So using the closest x-axis. The closest axis is 8 pi over 4. If you go backward, it's what? 7 pi over 4. Does that make sense? Does that make sense or no?
Yes.
Okay, now let's go to 30 degrees. Do you guys know what 30 degrees is equal to in terms of radians? Let's ask. What do you want? Give me eye contact.
Take the head, man. Take the head. Not
Okay, Caleb, what do you think? 30 degrees, what do you think?
Is it pi over 6?
Why do you think it's pi over 6?
Because 30 degrees is like it's 1/12 of 360.
That's one way to look at it. Or if 30 is 1/3 of pi over 2. Okay, so what's 1/3 times pi over 2? 1/3 times pi over 2. Right? So it's pi over 6. So this is 90 degree, right? Think about clock. So I think about clock. It's this 12 o'clock, right? This is 1 o'clock. This is 2 o'clock. This is 3 o'clock, right? So it's 3 hours split up. So it's 1/3. 1/3 of pi over 2. So therefore, this is pi over 6. So 1/3 times pi over 2 is pi over 6. Are you lost, Arthur?
No, I got the part.
You got it, part?
Oh, yeah, that's part.
Okay, so now do you know what 150 in terms of radians? Using the same idea, what's pi equal to? 4 pi over 4? I'll give you a hint. Pi is equal to 4 pi over 4. It's also equal to what? 6 pi over 6. So what does 150 becomes?
Wait,
Arthur?
why is the equal to 6 pi?
Well, 6 over 6 is what? Yeah, 1.
Okay.
6 over 6 is 1. 4 over 4 is 1. 1 over 1 is 1. Right? So if this is 6 pi over 4, and we know the opening is pi over 6 from here to here, so what will be here to here? So what will be this one here, Arthur?
Over 12.
No. Robert,
5 pi over 6.
can Can you explain or author why is 5 pi over 6?
Because the pi is 6 over 6.
Yeah, so 6 over 6, and you know this opening is pi over 6. Can I just track it back? Subtract 6 pi over 6 minus pi over 6 equal to 5 pi over 6. Is that okay? Arthur, do you understand? Are you sure you understand? Because I'm gonna ask you next question. If you don't understand.
I believe so. It's just minus 1 because it's up, right?
Yeah, so what would it be 210 is? What would be 210?
Not gonna be 7 or 6.
You were right. Good job.
1 divided
7 pi over 6. Why 7 pi over 6? Basically, you notice 6 pi over 6? That's 7 pi over 6, right? Elizabeth, can you tell me what 330 is?
what is exact? I was trying to figure.
330 right here. Look at right here. This is 8 pi over 4. What else can it be? No.
Oh.
8 pi over 4. So 2 pi is equal to 8 pi over 4 is equal to what?
Something over 6.
Something over 6. What's that something?
12.
12 pi over 6. You are absolutely right. So what that makes this one here? Yeah. 11 what?
Pi over 6.
Over 6. You're right. Same color. Okay? You guys understand how the reference angle now? See, the closest to x-axis, they all have pi over 6, right? They all have pi over 6, right? The closer to x-axis all have pi over 6. You guys remember that? 7, pay attention. Everything that's closer to x-axis is all pi over 6. Now, how about the one that's closer to y-axis? What's this one? If this is pi over 6, what is 60 degrees? Why is pi over 3?
Because you're like dividing it into thirds.
You can times 2, right? So pi over 6 times 2 is 2 pi over 6. 2 pi over 6 can simplify to pi over 3. So this is the pi over 3, right? Different color again. So different color, pi over 3. So what makes 120? 2 pi over 3. Why? Because this one is 3 pi over 3. So 3 pi over 3 go backwards, 2 pi over 3. 3 pi over 3 go forward, 4 pi over 3, and then 5 pi over 3. Because this is a 6 pi over 3.
Wait, why is that one 4 and 5?
What?
Why is those two 4, 5, and 3, 5?
Okay, so this is 3 pi over 3, which is 3.
Oh, okay.
And so if you're adding 60 degree on top of
Yeah.
this, it's gonna become 4 pi over 3, and this is 5 pi over 3.
Yeah.
Okay, so for today,
Wait, what's the 300?
5 pi over 3. 330 is 11 pi over 6 because that's pi over 6 away from 12 pi over 6. For today's goal, you only need to understand all the radian degree. Do not need to learn the rest of them because tomorrow we're gonna learn the rest of them. Today, your brain, it just come back from winter break. I don't want to overextend it. But just understand that particular part. But this is a good. This is a different color. So all the same color has the reference. We're gonna come back to the rest of them.
Why is
High rating. So if I do like 5 times 53 point whatever, maybe 180. I think I understand.
I contact. You can.
I don't know why they do. It's 6 pi over 3, right? And it's 6 pi over 3.
And explain to us why it's not 6 pi over 3.
Yeah,
Pi.
two pi, right, that's the, pi over pi x. Absolutely. I am okay. Remember that? Yeah. I would be two.
You are in the whole thing.
You know how you end like.
Wow. Yeah.
No, wait, you know how there's a two pi? Yeah. What? The closest. What, what's